Assalamualaikum warahmatullahi wabarakatuh. Thank you very much for the time that has given to us as Group 3 from Professor Fuad Abdul Hamid. I'm Irsyad, Buyani, and also Pak Sayrofi. In this opportunity, we would like to present some slides about basic descriptive and item statistic for Criterion reference test that still relates with the earlier discussion from Mbak Yuli and also Pak Munawir from previous chapter about quality of the test item from Criterion reference test. I've got some issues to be presented in this opportunity. The first one is significance difference between Criterion reference test and norm reference test. Second one is the example of Criterion reference test and norm reference test distribution. The third one is the discussion of mean, mode, median, range, and also standard deviation. And the last is item analysis. In this slide, I try to explain about the significance difference between Criterion reference test and norm reference test, like what we've understood from this chapter. In Criterion reference test, the scores are compared to a standard of passing performance called a Criterion level. Meanwhile, in norm reference test, each examinee's performance is compared to the performances of all the other examinees who belong to the norm group. Another difference that I can understand from this chapter is in norm reference test, the focus is on how the examinee's performance relates to the scores of all the other examinees. But on the other hand, in Criterion reference test is used for assessing the amount of material known or skills possessed by individual examinee. In this slide, I try to explain about the example from Criterion reference test scores distribution. The first figure is figure 4.1, tell us about the scores of number of students at the end of the course. We can see here that most of the students scored very high, with only a few students not keeping up with the group. It can be indicated that most of the students have a good achievement at the end of the test. In figure 4.2 will be obtained at the beginning of the course that most of the students have low scores at the beginning of the course. It's indicated that they didn't know the material at the beginning. So if we combine the both pre-test and post-test distribution, so the result will be as shown in figure 4.3, that pre-test distribution indicates that most of the students didn't know the material very well, while the post-test distribution indicates that most of the students had learned the material very well by the end of the course. In this slide, it explains about the norm reference test scores distribution. Figure 4.4 represents shape of the normal distribution that will be expected from well-designed norm reference tests. But on the other side, there is figure 4.5 that represent the approximate histogram of a set of scores in actual or in the real distribution of norm reference test scores. In this slide here, I'd like to explain, try to explain about the four statistical analysis about mean, mode, median, and also range. Mean indicates the score average. So if we take a look to the table 4.1, the mean is 31.11. This number was coming from the statistic calculation, sum of all student scores divided by the number of students. So the result is the mean. So in this table 4.1, it is stated that sum of all student scores is 1089 divided by number of students, 35 students. So the result is 31.11. Yeah, 31.11. Okay. Second one is mode. Yeah, mode, it's determined from a score that repeated more often than others. It's easily, if we see from the histogram on figure 4.5, we just only see the peak from the histogram, and the peak is 15, which has the highest peak from other sources. It means that most of students get scored 15. But on the other hand, if we take a close look to the table 4.1, the mode has two scores that most of students have, which are 29 and 35. Both have 4 students, so it's called bimodal. So if there are 3 modes, it means that mode has 3 scores, so it will be called trimodal, and so on and so forth. The third one is median. It's the middle score in the list. Yeah. So if we point to figure 4.5, it's revealed that the median is 15. But if we see the table 4.1, the median will be 27. And the last is the range, which is the difference between the largest and smallest scores from the list. The formula for calculating the range is the highest score minus the lowest scores with adding 1. If we take a look to the table 4.1, the highest score is 39 minus the lowest score 15. So it will be 24 and plus 1. So the result is 25. But if you take a look to figure 4.5, the highest score is 25 and the lowest score is 5. 25 minus 5 is 20 plus 1. So the result is 21. So the range for figure 4.5 is 21. Now we go to the standard deviation. Standard deviation, as defined in Brown in 1988, the standard deviation is a sort of average of the distances of the scores from the mean. And this is the formula. Standard deviation is equal to the sum of all scores minus mean and its squared divided by number of students, and all of the numbers get a square root. Standard deviation indicates how far the individual responses to a question vary from the mean. So the researchers know how spread out the responses are. Are they concentrated around the mean or far from the mean score? In this slide, I try to explain about the example of statistic result from hypothetical pretest and post-test result. This is the hypothetical result for 2 forms of criterion reference test. As we can see here, that number of students who involved in pretest for both form A and B is higher than the number of students who get post-test. As we can see, that number of students who get pretest for form A is 88, then in the post-test only 79. For Form B, the number of students who get a pre-test is 97. Then in the post-test decreased to 86. So we can assume that maybe some of the students drop out from the courses. The next is K. K belongs to number of questions or item. The number of items on each test is exactly the same, 50. So if we take a look to the mean, it has progression on the post-test score than pre-test score. So we can assume that the students have learned very well from the course. In terms of distribution, the standard deviation of each test in these forms, both form A and B, has a lower score than the mean. As we can see here, that score for standard deviation for form A are 4.15 and 5.10. And then for form B are 12.59 and 5.92. And those scores are lower than the mean scores. So we can conclude that the questions have normal data distribution. After we've known about the statistical analysis score of mean, median, mode, range, and also standard deviation, now we have the item analysis. In this chapter, it can be defined as the systematic statistical evaluation of the effectiveness of individual test item. Item analysis purpose is selecting which item will be remain or revised, and also to investigate how well the items on a test are working with a particular group of students. There are 2 traditional item analysis. The first one is item facility and item discrimination. And the second one is item discrimination. Item facility goes by many other names. Item facility goes by many other names. Item difficulty, item easiness, v-value, or just abbreviated simply as if. Item facility expresses the percentage students who answered a particular item correctly. And here is the example of the item analysis data. We can see here that for the correct answer, it's labeled by 1, then for the incorrect answer, it's 0. From this table, we can also predict that for question item number 4 and 10, it will be an easy question to be answered because all of the students can answer it correctly. But on the other hand, the question number 8 and 9, most of the students cannot answer it correctly. So it will be a hard question for the students. And if we want to know the scores for item facility from this question, we can use the formula that is number of questions that answered correctly divided by the total number of all students. For example, if we want to know the e-value for question number 10, so it's 14 students who answer it correctly divided by 15 number of all students. So it will be 0.93. So it's 93%. Next example for question number 8. It's only 5% who can answer it correctly. So it will be 5 divided by 15. So it's 0.23. It's 33%. Okay, so the next slide, it's about the item discrimination or ID. It shows the degree to which an item separates the upper examinees, which is the student who get the high scores, from the lower ones, which is student who get lower scores. If we want to know the ID value, first we have to calculate the if upper value and if lower value. So the question is, how can we differentiate between if lower and if upper? And the answer is using median. We have to know the median. We have to see the median. In this table, we can see the median percentage, which is stated from 67% below. So 72% above, it belongs to the upper, if upper value. In this slide, it's example of the item statistic. In this example, we can see the score for item facility, and then if upper, if lower, and item discrimination. For example, if you see the item question for number 3, which has if upper 100% or 1.00, it means that all the highest score students can answer the question correctly. But if lower score is 0% or 0.00, it means that all the low score students cannot answer it correctly. So we can accept that the question number 3 will be considered a very good discrimination index. Another example for the question is number 6, where if upper 0% or 0.00, but if lower, it's 100% or 1.00. So the score ID is -1 or -1.00. This item 6 will be left out from the test, because students who get high score cannot answer the question correctly, but the student who get lower score can answer it correctly. And now we go to the final slides of my presentation. It can be concluded that the test revision process for item facility and item discrimination are accomplished by keeping the best item and discarding weak ones. The choices are generally made on the basis of some set of rules. Typically, items are selected if they have an item value generally 0.40 and above, from 1981. And I think that's all for my presentation. Thank you for your all attention, and sorry for the mistakes. For the next presentation, it will be delivered about criterion reference item analysis by Buyani. And Buyani, the time is yours.